If a creature larger than Megalodon does inhabit the Pacific, its continued secrecy says as much about human limitations as it does about the animal itself. The vast majority of the deep ocean has never been surveyed with high-resolution tools. Expeditions focus mainly on limited areas of economic or scientific interest, leaving immense stretches of water virtually unobserved. Large animals that avoid surface layers and noisy human routes could pass their entire lives without crossing paths with direct observation. The difficulty of definitive proof arises from several factors. Visual confirmation in deep water requires specialized cameras, robust lighting, and stable platforms. These systems are expensive and technically demanding, and they seldom remain in one place long enough to intercept rare mobile giants. Acoustic tools can detect movement and estimate size, but they do not reveal precise shape or exact identity. Even when a large body is detected, distinguishing an unknown predator from overlapping reflections or from clusters of smaller animals remains challenging. There is also an institutional reluctance to embrace extraordinary possibilities without extraordinary evidence. Scientific culture rightly demands strong proof before revising established narratives. The idea of a predator surpassing Megalodon in modern times challenges assumptions about deep-sea productivity, energy budgets, and evolutionary history. Many researchers prefer to interpret anomalies as unusual combinations of known processes rather than as signs of a new apex species. This caution protects science from hasty conclusions, but can also slow the exploration of unconventional hypotheses. Nevertheless, interest in the possibility continues to grow as new data appears. Improvements in satellite tracking of whale migrations, advances in deep autonomous vehicles, and extended deployments of listening networks are gradually filling in blind spots. Each year brings more detail about how life operates in deep basins, along seamount chains, and inside trenches. With increased coverage, chances rise that a decisive encounter may occur, whether through a clear acoustic profile, an unmistakable video record, or the recovery of a large modern tooth unlike any fossil yet known. The implications of confirmation would be significant. The presence of a living predator larger than Megalodon would require revisions to textbooks, documentaries, and public understanding of ocean ecology. Conservation planning would need to consider the health of food chains extending into the abyss. Whale populations would be viewed not only as charismatic creatures to protect, but also as vital components of a hidden energy network that sustains giant deep predators. The role of the Pacific in global carbon cycling and nutrient transport might require re-evaluation in light of massive animals moving and feeding in its depths. On a philosophical level, such a discovery would remind humanity that control over the planet is partial and recent. Despite satellites, global communication, and immense scientific databases, an enormous predator could still glide unseen through ancient waters, shaped by evolutionary pressures that predate our species. Its existence would underscore the fact that knowledge of Earth remains incomplete and that humility is appropriate when speaking about the limits of nature. For now, the evidence forms a compelling but inconclusive pattern. Oversized bite marks, damaged structures, deep sonar silhouettes, and resonant calls point towards something vast and powerful in the Pacific. That something may be a unique mixture of physical phenomena and misunderstood behavior of known animals. Or it may be exactly what the converging lines imply. A creature larger than Megalodon, hidden in the cold silence beneath the waves, following routes carved over geological time. Indifferent to the curiosity of a land-bound species just beginning to listen properly to the deep. For more than a century, the largest known predator ever to live in the ocean has been presented as the giant ancient shark called Megalodon. Its teeth fill museum cases, its jaw is reconstructed in aquariums, and its image dominates popular imagination as the ultimate marine hunter. The accepted narrative states that this massive shark vanished from the oceans several million years ago, leaving modern seas ruled by smaller descendants and other large predators. Yet scattered lines of modern evidence collected from the Pacific Ocean suggest that the story of the largest predator may not be complete. The idea that something even larger than Megalodon may exist sounds like speculation from fiction rather than serious science. However, the Pacific is vast beyond intuitive human understanding. It covers an area greater than the surface of all continents combined and reaches depths where pressure crushes conventional equipment. Only a small fraction of this volume has been observed directly. Most of what is known about its interior comes from indirect readings, such as acoustic measurements, satellite-driven gravity maps, and samples drawn from narrow paths. Within this immense and largely unobserved space, certain anomalies have accumulated over the past decades. They do not align neatly with known geological processes or with the activities of documented species. These anomalies cluster in deep trenches and remote open water zones, far from major shipping routes and fishing grounds. They involve vast moving shadows on sonar maps, unexplained damage to extremely tough structures, and rare but powerful acoustic signatures unlike any cataloged whale song. The first hints arrived in the form of unusual bite marks on large marine animals. Carcasses of great whales found adrift in remote regions occasionally displayed enormous semicircular gouges that did not match the dental patterns of known predators. These wounds indicated an attacker with a mouth width far exceeding that of modern sharks and orcas. In some cases, the spacing and curvature of the marks resembled the general layout of megalodon tooth arches reconstructed from fossils, but at a slightly larger scale and with fresher, modern edges. Parallel to these observations, deep-sea monitoring programs recorded disturbances difficult to reconcile with known sources. Seafloor cables, designed to withstand extreme tension and mechanical stress, were found torn or scored over broad sections, as if gripped by a vast jaw. Reinforced submersible hulls recovered after accidents showed localized compression patterns that hinted at external bite forces rather than simple pressure failure. Official reports usually attributed such events to landslides, entanglement, or flawed construction, yet internal technical notes sometimes expressed quiet doubt. The Pacific offers many ways for the imagination to fill gaps, and scientists are trained to resist dramatic explanations. Nevertheless, the recurring combination of oversized bite marks, powerful mechanical damage, and acoustic events resembling very large moving bodies raised questions that would not easily go away. If these signals originated from a living organism, then that organism would exceed Megalodon in overall size and perhaps in mass. Megalodon itself is estimated to have reached lengths of 15 to 18 meters, possibly more, based largely on tooth size and comparisons with modern relatives. Any creature producing the largest observed damage in the Pacific would require a body plan at least comparable in scale and likely surpassing it. The lack of a fossil record for such a modern colossus is not surprising, because the deep ocean seafloor is an environment where bones are quickly buried, scattered, or dissolved, leaving minimal traces for later discovery. This chapter establishes the context for a hypothesis that remains controversial. No single piece of evidence proves the existence of a creature larger than Megalodon, yet the convergence of indirect observations is difficult to ignore. The Pacific, with its trenches deeper than the height of the tallest mountains, may shelter more than geological secrets. It may harbor an apex predator that has learned to avoid the brightest layers of the sea and the technologies that probe them. Modern understanding of the deep Pacific relies heavily on sonar and acoustic networks. These instruments send pulses of sound through the water and listen for returning echoes, revealing shapes, densities, and movements that light can never reach. When such systems are deployed over long periods, they record not only expected phenomena, but also inexplicable patterns. Among these patterns are a series of moving returns consistent with a single massive entity traveling along what some researchers informally call the abyssal corridor. This corridor stretches along the margins of major trenches and deep basins, following chains of underwater mountains and ridges. It lies far below the productive sunlit layers, within regions that seem empty on most biological surveys. Yet sonar records occasionally show vast, elongated forms moving with coherent direction through this zone. Their acoustic signatures do not correspond to schools of fish or groups of whales. Instead, Each form behaves as a single, continuous body extending tens of meters in length, sometimes more. The speed of these entities is notable. They move faster than typical deep-water currents, yet slower than the rapid bursts of known pelagic predators in surface layers. Their motion suggests a sustained cruising mode, suitable for large creatures that conserve energy over long distances as they patrol for scarce prey. When they approach slopes or seamounts, sensors detect subtle changes in local water density and temperature, implying powerful internal engines that displace surrounding water on a significant scale. Occasionally, the passage of such a form coincides with an acoustic event that resembles a low, resonant call. These calls occupy a frequency range that overlaps with the lowest rumbles of baleen whales, but extend further downward and maintain a smoother, more continuous structure. The amplitude suggests a sound source larger than any documented animal. The calls appear rarely, as if the creature vocalizes only under particular conditions, perhaps during feeding or navigation in complex terrain. Another strand of evidence arises from the behavior of deep-dwelling prey species. Certain squid populations and large fish groups show sudden, coordinated movements in the presence of these sonar-tracked bodies. Vertical migrations accelerate, and entire aggregations change course as if avoiding a threat. Similar reactions occur near known whale feeding grounds, but the scale and depth of these responses in the Pacific corridor exceed typical predator avoidance. These prey reactions may map out the routes of something truly enormous and feared. Ocean current models provide further context. The abyssal corridor lies along paths where cold, nutrient-rich waters travel slowly through the basins. These flows can support a hidden food web based on sinking organic material from surface layers and on chemosynthetic communities at hydrothermal vents. Such a web could sustain very large predators that have adapted to feed on deep-water fish, squid, and perhaps even whales that dive through these zones. A creature larger than Megalodon would require a substantial energy supply, and the corridor offers a plausible route that connects multiple feeding regions across the Pacific. The challenge lies in distinguishing living bodies from unusual clusters of physical conditions. Internal waves, temperature fronts, and suspended particle layers can all produce complex sonar returns. Scientists are cautious in labeling any given form as biological. However, repeated tracking of mobile, self-consistent shapes that turn, accelerate, and avoid obstacles suggests more than passive water structures. When such forms appear near unexplained damage to equipment or coincide with rare, powerful acoustic calls, the case for a giant living entity grows stronger. What emerges from this chapter is a picture of a deep migratory highway, often empty in records but occasionally traversed by something huge, deliberate, and quiet. This corridor does not prove the presence of a creature larger than Megalodon, yet its patterns outline the probable routes such an animal would use if it exists. The corridor is the spine of a possible hidden life history, stretching from one edge of the Pacific to the other beneath many kilometers of water. With only indirect observations to work with, researchers interested in the possibility of a creature larger than Megalodon must use methods similar to those employed by paleontologists who reconstruct extinct animals from fragmentary remains. Instead of bones and teeth, the modern investigation relies on bite damage patterns, sonar silhouettes, acoustic power, and ecological constraints. From these threads, a tentative image of the hypothetical predator can be woven. First, consider size. The largest semicircular gouges on whale carcasses and on extremely strong artificial structures imply a jaw span greater than that of any known shark. If the spacing between presumed tooth impacts is measured and scaled by comparison with fossil records, the implied body length surpasses traditional megalodon estimates. Some analyses suggest a creature approaching 20 meters or more, with a body mass several times that of the largest great white sharks and surpassing that of the average adult blue whale in terms of muscular bulk. Second, examine depth tolerance. Evidence places the entity in waters far deeper than those frequented by most modern large predators. To survive at such depths, it would require specialized adaptations. Cartilage-based skeletons resist crushing and can bend under pressure, offering an advantage over rigid bone structures. A massive oil-rich liver or equivalent buoyancy organ would help control position in the water column. Muscle fibers would need to operate efficiently in cold, oxygen-limited conditions, resembling or exceeding the abilities of deep-diving whales. Third, consider feeding strategy. A creature of this magnitude must secure large quantities of energy. One plausible strategy involves ambush predation along the migration routes of whales and large fish. By lurking in dark depths below common paths, the predator could launch upward attacks at unsuspecting animals returning from deep dives. Alternatively, it could patrol the abyssal corridor and intercept schools of large squid and deep-water fish, using sudden bursts of speed and immense suction or bite power to capture many individuals at once. The structure of the head and mouth can be inferred from damage patterns. Deep punctures and broad arcs suggest robust jaw muscles and thick triangular teeth capable of cutting through bone, blubber, and even synthetic materials. The teeth might be fewer but larger than those of Megalodon, optimized not for shearing small prey, but for disabling enormous targets in a single attack. Serrated edges would allow rapid removal of large chunks of tissue, while a powerful tail and streamlined body would enable quick retreats back into the gloom. Acoustic observations hint at a communication or navigation system based on low-frequency sound. To generate such powerful calls, the creature would require spacious resonating cavities, possibly within the skull or along the respiratory tract. These sounds could serve multiple functions, including long-range contact with others of its kind, mapping of underwater landscapes through reflected echoes, or coordination during rare breeding events in deep, secluded basins. Ecologically, the presence of such a predator would have profound effects on deep Pacific ecosystems. It would sit atop the food web, influencing the behavior and distribution of whales, large fish, and deep scattering layer communities. Prey species might alter migration routes or diving patterns in response to its recurring presence, much as animals on land adjust their movements around territories of large terrestrial predators. Indirect traces of these influences can sometimes be seen in unusual shifts in animal behavior recorded by tagging studies, though direct attribution remains uncertain. This chapter does not claim that the described creature definitely exists. It presents a coherent model that satisfies the physical and ecological constraints implied by the observed evidence. The model yields an animal larger than Megalodon, specialized for life in the darkest waters of the Pacific, equipped with enormous jaws, immense strength, and remarkable endurance. Whether nature has actually produced such a being remains the central, unresolved question. We upload new videos every single day, so make sure to subscribe and turn on the notification bell so you never miss what's next. If you enjoyed this video, don't forget to leave a like, it really helps the channel grow. Tell us in the comments what you'd like to see next. Your ideas might be in our next upload. Thank you so much for watching and for being part of our community. Stay tuned, stay curious, and we'll see you in the next video.